right, today we're going to be talking about the properties of a square, and we're going to be talking about some special right triangles. So not only are we going to say, what a square is, we're going to show you how it turns into a special right triangle. So there's a couple things you should know about a square. You should know that all sides are congruent. All these sides here are totally congruent, and all your angles are congruent too. And not only that, if they're all congruent, all the angles must be 90 degrees. So all these are 90 degrees. Now, if I drew a diagonal right from one vertex to the opposite vertex, that would split my 90-degree angle into two 45-degree angles, okay? And when this happens, special things end up happening. But before we get into that, let's go ahead and investigate what happens. I have that right down here. Find the length of the diagonals and the missing side. So a diagonal goes from vertex to vertex. First thing, if this is a square, and this length is 3, then if it's a square, this length must also be 3. And you do know something that you could use to work this out, and it's the Pythagorean theorem. So if I call this A, B, and C, we would say that A squared plus B squared equals C squared. And we know that A is 3, and we know that B is 3. So 3 squared plus 3 squared equals C squared. And we know that 3 squared is 9, so 9 plus 9 equals C squared. And then 9 plus 9 is 18, so 18 equals C squared. And the inverse of squaring is square rooting. So we take the square root of 18, and we would get C. And then we can't leave 18 like that. We have to break it up. So that's 9 and 2, and then this would be 3 and 3. So we know that this is going to be 3 root 2. So C equals 3 root 2. And I'm going to write it here, 3 root 2. So there's our C, and then there was our other side. All right, well, we can't see a pattern unless we do this twice at least, right? So if this side's 4, and this is a square, this side must also be 4. And then just like we did on the last problem, we can use the Pythagorean theorem. So we'll say this is A, B, and C, and then A squared plus B squared equals C squared. So 4 squared plus 4 squared equals C squared. We know 4 squared is 16, so this is 16 plus 16 equals C squared. 16 plus 16 is 32, so 32 equals C squared. And then we take the square root to undo a square, but you cannot leave the square root of 32. You have to break it up with a factor tree. So we take 32 and we break it up, and this will break into, you can do 16 times 2, you can do 8 times 4, whatever floats your boat. Then we break up 8 into 4 and 2, and 4 is 2 and 2. And remember, when I do factor trees, I like to bring everything down. So this is 2, 2, 2, 2, 2. We have a pair of 2s, and there's a little 2 left inside that doesn't get to come out. So we have 4 root 2 as our answer for C then. So C is 4 root 2. So I'm going to write it here also, 4 root 2. Let's talk about a pattern that you might see here. 3, 3, 3 root 2, 4, 4, 4 root 2. So this triangle right here, this 45, 45, 90 triangle, let's see if we can use the pattern over here. So 5, 5, what's this going to be? 5 root 2. So this one is the pattern. So hopefully you can see the pattern there. And we're going to talk about that pattern in this little box down here. So this is a 45, 45, 90 triangle, and you will have a different triangle that we talk about later. But for now, we're going to focus on this, and it always comes from a square, and you will need to know that later because we're going to start mixing in a different kind of triangle other than a square, or a different kind of quadrilateral. Actually, it's just going to be a different kind of triangle. Just know that a 45, 45, 90 will come from a square. So they can draw the triangle this way, or they can say because these two sides are congruent, these two angles are congruent, and that's still a 45, 45, 90. Or they can say these two angles are congruent. Well, if they're congruent, that must be a 45, 45, 90 also. So what you always want to do on these triangles is you want to label your sides. Always, 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 in all these problems, label your sides. So here's how you're going to label a 45, 45, 90 triangle. Across from the 90-degree angle is always your hypotenuse. And to find the hypotenuse, what did we do? We took the side and we multiplied it by root 2 in all 3 of these examples. So we're going to do the same thing here. It's going to be the side times root 2. And then we'll just call these the sides. And since they're the same, we'll just label them the same as side and side. Let's actually apply this pattern to number 1. So first thing, we know it's a 45, 45, 90 triangle. We always label the sides first. So this is side, and this is hypotenuse. Well, we know this side is 8, so this side must also be 8. And we know that the hypotenuse is the side times square root 2. Well, what is our side? It's 8. So our hypotenuse then is 8 times square root 2. And that's as far as you can go, so you're done with that one. Let's look at 3 real quick. On 3, do you notice that it's a 45, 45, 90 because these two are the same? Label it. So we have side, and we'll call this our hypotenuse. Well, we know the side is 5 root 2, so this will also be 5 root 2. And we know that our hypotenuse is the side times square root 2. So our hypotenuse in this situation is going to be the side, which is 5 root 2, times root 2. And we have some innies going on here. So our hypotenuse then is 5 square root 4. And what is the square root of 4? It's 2. So our hypotenuse then is 5 times 2, which means our hypotenuse is 10. There we go. Now we've taken care of all those sides. I'm going to ask that you do number 2, bring that to class. So try that one out and bring it to class, and we'll talk about it then. So let's keep going. And remember, you can always pause, you can always rewind if I'm going too fast. Let's talk about number 4. Label it the same. So we have side, we have the side, and here we have the hypotenuse, which is the side times square root 2. Well, we don't know the sides, but we do know the hypotenuse is 11 root 2. And we know that that hypotenuse equals the side times square root 2. Well, if I want to get the word side alone, how do I do the inverse of times square root 2? What is the opposite of multiplying by square root 2? It's going to be dividing both sides by a square root 2, just like this. So now we have 11 equals the side. So now we can actually go label that in our triangle. So this is 11, and this is 11. Done. So we worked backwards on that one. So on number 5, we have the same deal going on. This is the side, this is the side, and here our hypotenuse, which is the side times square root 2. Well, what have they given me? They've given me the hypotenuse, and I need to find the side. So my hypotenuse is 12, and I know that that's the side times square root 2. To get the word side alone, we'd have to divide by the square root of 2 on both sides. So 12 divided by square root 2 equals the side. But you cannot leave a radical on the bottom. So let's rationalize this by multiplying the top and bottom by the radical that is on the bottom. Once we do this, we have 12 square root 2 over the square root of 4. The square root of 4, though, is 2. And then we have outies, 12 and 2. Those are our outies. So 6 root 2. That's going to be our side. So I didn't bring that word down the whole way, which I should have, but that's going to be our side. So we'll go over here and we'll write 6 root 2 on both of these, just like that. I'd like you to try 6 and bring that one to class with you. Go ahead and try that one and bring that one to class. I'm going to skip 7 for now because I want to talk about 8. It says the length of the diagonal of a square is 24 feet. So they're saying that the diagonal is 24 feet. So your 24 goes here. What is the length of the side? Well, we have side. So the same thing. You're just drawing your own picture. Side, side, hypotenuse. We know the hypotenuse is the side times square root 2. In our case, they gave us the hypotenuse. So that equals the side times square root 2. But you've got to get the word side alone. And since square root of 2 is being multiplied, we're going to divide both sides by a square root 2. But you cannot leave that. No radicals in the denominator. So let's multiply the top and bottom by the radical. So on the top we have 12 root 2. And on the bottom we have the square root of 4. But we know that the square root of 4 is 2. So we have 12 root 2 over 2. And we know that 12 and 2 are outies. So 12 divided by 2 is 6. So that is going to be the length of one of the sides. And we need to write feet. Okay? I would like you to try number 7 and bring that to class. I think you can handle number 7, and then I will discuss 9 and 10 with you guys in class, okay? And if you need to rewind and rewatch, please do that. I know that this is a little tough for some people. It is the same thing over and over again, so watching it again might help you understand it better. All right, so finish up the ones I said to finish up for class, and I'll talk about 9 and 10 when I see you. Have a great night.